problem is if 5.4 meter cube of certain oil weighs 45 kilonewtons, you have to calculate specific weight, mass density and specific gravity. So here volume is given, that is 5.4 meter cube. Weight is given 45 kilonewtons. So you have to find specific weight. You know that specific weight is weight by volume. So first convert weight, that is 45 kilonewton to newtons, by multiplying by 1000. So the volume is given as 5.4 meter cube. So weight is 45. So 45 into 1000 gives 45,000 newtons. So now you can calculate specific weight, which is weight by volume. So 45,000 divided by 5.4. So that gives 8333.33 Newton per meter cube. So therefore specific weight of oil is 8333.33 Newton per meter cube. So now you know specific weight. So specific weight is nothing but rho into G. So therefore the density can be calculated. So specific weight is nothing but rho into G. So take specific weight and divide by 9.81. You will get rho, which is in kg per meter cube. So mass density is nothing but specific weight divided by acceleration due to gravity. So therefore you take 8333.33 divided by 9.81. So you will get 849.47 kg per meter cube. So if you substitute, that's what I told in the concepts, that whenever you substitute the units in Newton, meter and seconds, so you will get for mass density the units as kg per meter cube. So now specific gravity, either you can take, it is specific gravity of oil is specific weight of oil, which is 8333.33 divided by specific weight of water, which is 9810, or you can also find out specific gravity by mass density of oil, which is 849.47 divided by mass density of water, which is 1000. So you get the specific gravity is 0.8495. So specific gravity of oil is specific weight of oil divided by specific weight of water, which is you get as 0.85. So also you can find out specific gravity of oil by mass density of oil divided by mass density of water. So mass density of water is 1000 kg per meter cube. So you should get 0.85 as the answer. The second problem is if certain liquid has a mass density 132 metric slug per meter cube, calculate specific weight, specific gravity and specific volume. So here the first step is to convert metric slug to kg. So that means mass density has to be expressed in kg per meter cube. So if you multiply by 9.81, 1 metric slug is 9.81 kgs. So therefore the conversion is that mass density is 132 into 9.81. You will get 1294.92 kg per meter cube. So first you can calculate specific weight. So specific weight, you know that is rho into G. So if you multiply this by 9.81, so you will get specific weight. So specific weight is rho into G. I told you that if this is in kg per meter cube and this acceleration is in meter per second square, you should get the answer in Newton per meter cube, which is the unit of specific weight. So therefore as far as possible stick to the SI units like mass in kgs, length in meters and time in seconds, so that you will get force as newtons. So whatever answer you get will be Newton per meter cube, because that is the unit of specific weight. Now specific gravity can also be calculated by means of specific weight or by means of mass density. So specific gravity is nothing but mass density of liquid divided by mass density of water. So if you divide by 1000, it will be 1.294, or you take specific weight, which is 12703, divided by 9810. So therefore specific gravity is specific weight of liquid divided by specific weight of water. So therefore you should get 1.29. Or you can also find out specific gravity as mass density of liquid is 1294.92. You divide by 1000, you will get 1.29 as the answer. So now since it is a liquid, specific volume is 1 by specific weight. So that is 7.87 into 10 raised to minus 5 meter cube per newtons. So third problem is the specific gravity of the liquid is given. So you can find out what is specific weight, mass density and specific volume. So you can make use of the definition of specific gravity. I told you that so in order to find a specific weight of any liquid, you have to take its specific gravity and multiply by specific weight of water. So then you will get specific weight. So also mass density of any liquid is to can be determined by taking its specific gravity and multiplying by 1000, which is mass density of water. So specific weight of any liquid is specific gravity of that liquid into specific weight of water. So 3 is the specific gravity. So 3 into 9810 gives 29430 Newton per meter cube. So mass density is again specific gravity of the liquid into mass density of water. So 3 into 1000, so which is mass density of water, which is 3000 kg per meter cube. So specific volume, you know that is 1 by specific weight is 1 by 29430 meter cube per Newton. So which comes to 3.398 into 10 raised to minus 5 meter cube per Newton. Now a certain liquid has a dynamic viscosity, that is mu is 0.075. I told you that in order to convert poise to Newton second per meter square, you have to divide by 10. So it will be 0.0075 Newton second per meter square. Specific gravity is given, which is 0.87. You have to compute kinematic viscosity in terms of Stokes. You know that Stokes is nothing but centimeter square per second. So here the first step is to convert dynamic viscosity, that is poise, to Newton second. So we are dividing by 10. So because one poise is 1/10 of Newton second meter square, so you divide by 10, so you get 0.0075 Newton second per meter square. Specific gravity is given in order to calculate density. So therefore the mass density of any liquid is take its specific gravity and multiply by 1000, so you will get 870 kg per meter cube. Now you know mu, which is in SI units, which is 0.0075. Rho, you know, again it is in SI units, which is 870. So mu by rho is nothing but nu. So kinematic viscosity of liquid is mu by rho. So directly substitute 0.0075 divided by 870. That comes to 8.62 into 10 raised to minus 6 meter square per second. So you know that 1 meter square is 100 square centimeter square. So therefore if you multiply by 100 square, so you will get 0.0862 centimeter square per second. 1 centimeter square per second is nothing but Stokes. So therefore kinematic viscosity of the liquid in Stokes is 0.0862 Stokes. If certain liquid has a viscosity of 0.052 poise, so therefore you divide by 10, it gets converted to Newton second per meter square. Kinematic viscosity is given as 3.6 to 10 raised to minus 2 Stokes, but Stokes is nothing but centimeter square per second. If you divide by 100 square, it gets converted to meter square per second. So now all the units should be Newton second meters. Okay. So therefore dynamic viscosity, you are dividing by 10 because it is given in poise, so therefore it is 0.0052 Newton second per meter square. You know that Stokes is 3.6 into 10 raised to minus 2 Stokes, which is 0.036. If one Stoke is nothing but centimeter square per second, I have to divide by 100 square, so that I will get in meter square per second. So this is how it is calculated in meter square per second. Now I need specific gravity, mass density and specific weight. Okay, I'll use the definition of nu. So nu is mu by rho. So therefore that will enable me to find out mass density. So therefore mass density is nothing but mu by nu, because nu is mu by rho. So if I take mu and divide by kinematic viscosity, I'll get mass density, which is 1444.44 kg per meter cube. So that's the unit in SI units, so which is kg per meter cube. So if I divide this by 1000, Okay, mass density of liquid divided by mass density of water, I'll get specific gravity. So therefore I can find out even for example, or before that, if I want to find out specific weight, I can take rho and multiply by g. So therefore I have multiplied by g, which is 14169.96 Newton per meter cube. Specific gravity is nothing but specific weight divided by specific weight of water. So if I divide, so it is 1. Or you can also calculate from mass density. So I have taken specific weight divided by specific weight of water. So therefore I got 1.44. Or I can take mass density, which is 1444.44 divided by 1000, which comes to 1.44. So these very important problems such like this, where it makes use of the basic definitions of the fluid properties. So in a stream of glycerin in motion at a certain point, the velocity gradient, so that is this term is velocity gradient is nothing but dou v by dou y, which is 0.25 1 by second, and mass density is given, which is 129.5 metric slug per meter cube. So you can multiply by 9.81 and convert to kgs. Kinematic viscosity is given, which is 6.3 stokes, but 6.3 stokes is nothing but centimeter square per second. You can divide by 100 square to convert to meter square per second. So first step is to write the units properly. So velocity gradient is given dou v by dou y 0.25. Density I'm trying to convert to kg. So multiply by 9.81. So it will be 1270.4 kg per meter cube. Similarly, Stokes is converted. 6.3 Stokes is kinematic viscosity. So Stoke is nothing but centimeter square per second. So if you divide by 100 square, I'll get 0.00063 meter square per second. So I have to divide by 100 square to convert into meter square per second. Now since dou v by dou y is given and shear stress is asked, I can use Newton's equation of viscosity. So because shear stress is mu into dou v by dou y, so using rho and nu I can find out mu. So therefore nu is nothing but mu by rho, so mu is nu into rho. So therefore nu into rho, take nu, which is this in SI units, meter square per second, multiply by 1270.4 kg per meter cube, so that I'll get the answer in Newton second per meter square. So now knowing mu, knowing dou v by dou y, I can find shear stress. So shear stress is mu into dou v by dou y, which is 0.800352 into 0.25, which will be 0.2 Newton per meter square. Here the equation of velocity distribution over the plate is given, which is given by velocity. Either it will be given as u or v. So v is 2y minus y square, in which v is velocity in meter per second and y is the distance measured in meters. So what is the velocity gradients and shear stress at the boundary and at 7.5 centimeters and 15 centimeters from the plate? Here given the dynamic viscosity is 8.6 poise. So dynamic viscosity is again given in poise. You have to convert to Newton second per meter square by dividing by 10. So therefore dynamic viscosity mu is 0.86 Newton second per meter square. Here the velocity is given, which is 2y minus y square. So you differentiate this to get velocity gradient. So that is dou v by dou y, which will be 2 minus 2y. Now I want velocity gradient at the boundary, so therefore y has to be 0. So when at y is equal to 0, dou v by dou y will be 2, that is 1 by second, 2 1 by second, or second to the power of minus 1. So shear stress will be mu dou v by dou y. So mu is in SI units, which is 0.86 multiplied by 2. That gives the answer 1.72 Newton per meter square. Now at y is equal to 7.56, so you have to be careful here. So since y is measured in meters, so this has to be divided by 100, so that then only y, that 7.5 divided by 100 has to be substituted in the velocity gradient, and then you will get the shear stress value. So that's what done is. So don't take y is equal to 7.5 centimeters. It has to be divided by 100. So 0.075 has to take 75 meters has to be taken in the equation. So therefore dou v by dou y is 2 minus 2y, that is 2 minus 2 into 0.075, which comes to 1.85 second to the power of minus 1. So therefore if you substitute in the Newton's equation of viscosity, so mu is 0.86 into 1.85 gives 1.59 Newton per meter square. Similarly, at y is equal to 15 centimeters, so don't substitute 15 centimeters, you have to divide by 100 and substitute as 0.15 meters in the equation. So therefore dou v by dou y is 2 minus 2 into 0.15, which comes to 1.71 by second, which is velocity gradient, and therefore shear stress will be mu dou v by dou y. So 0.86 into 1.7, which gives 1.462 Newton per meter square. So the next problem is hydraulic lift consists of 25 centimeters diameter ram which slides in a 25.015 centimeters diameter cylinder. The space between the ram and the cylinder is filled with oil of kinematic viscosity 0.025 centimeter square per second and specific gravity 0.85. So weight of the ram is 10.55 newtons. You have to calculate the rate of travel of the ram when 3.05 meters of the ram is engaged in the cylinder. So this is again, so here the ram is a moving part, whereas the cylinder is the stationary part. So we have studied in Newton's equation of viscosity that so if one part is moving, another part is stationary, and the gap is filled with any fluid, then we can apply Newton's equation of viscosity. So also here the Newton's equation of viscosity, shear stress is mu dou v by dou y is again applied. So now here the diameter of the ram, that is the moving part, so that is taken as capital D, which is 25 centimeters, which is 0.25 meters, and it slides in a cylinder. So the gap is now, the gap between the cylinder and ram is 25.015 minus 25, since there are two gaps, so divide by 2. So therefore so that will be y, and the kinematic viscosity is given in centimeter square per second. You have to divide by 100 square to convert to meter square per second, and specific gravity is given to calculate the mass density. So if you multiply by 1000, so 850 kg per meter cube is the density of the oil. So weight of the ram is given, which is 10.55 newtons. So we have to calculate V here. So when the length L, 3.05 meters of the ram is engaged in the cylinder. So the data is here, the diameter. So this is the outer cylinder, which is stationary, which is 25.015. So convert into meters. So the moving part is the ram, so that is represented as D always. So 25 centimeters, which is 0.25. So kinematic viscosity is given as 0.025 centimeters square per second. Centimeter square divided by 100 square to convert into meter square per second. Specific gravity is 0.85. So now weight of the ram, so here the force is always applied in the direction of the movement. So since weight is acting downward, so that will become the force, shear force applied, which is 10.55 newtons. Here length is 3.05 meters. I told you that the distance y is always the here, and that is the gap between the moving part and the stationary part. So this is what, so this the ram is, so this is ram, okay, this is ram, and this is the cylinder. I told you that ram is 25 centimeters, this is 25, so this gap is y. So therefore y is 0.25015 minus 0.25 divided by 2. So that means I converted into meters. So therefore it is 7.5 into 10 raised to minus 5 meters. Now the weight is, the shear force is in the direction of the movement. So therefore F has to be equal to W. So before we go for the calculation, so mass density of oil has to be calculated, which is 0.85 into 1000. Okay, so 850 kg per meter cube. So now you know that nu is mu by rho, so therefore mu can be calculated. So mu is nu into rho. So here it is already converted into meter square per second. So multiply by 850 kg per meter cube. So you will get mu in Newton second per meter square. So now you know mu. So you can use Newton's equations of viscosity. So before that, I need because shear stress is force divided by area. So what is the area? So it is the area of the moving part in contact with the fluid. So moving part, so that it is a ram which is of diameter d. So therefore pi into d, circumference into length, will give the surface area. So therefore surface area is pi d into L. So here d has to be taken as 0.25, L is 3.5. so therefore you will get the surface area of the ram. So now using shear stress mu dou v by dou y, you know that by linear relationship, so dou v by dou y can be written as v by y. So now shear stress is force divided by area, so therefore velocity can be calculated. So therefore v is nothing but f into y divided by a into mu. So therefore velocity is 0.156 meter per second. Next problem is a rectangular plate of size 25 centimeters by 50 centimeters is weighing 400 newtons, slides a 40-degree inclined surface at a uniform velocity of 2 meter per second. If the gap between the plate and, that is 2 mm gap between the plate and inclined surface, is filled with oil, that would mean the viscosity of the oil. So again here the rectangular plate is a moving part, whereas inclined surface is a stationary part, but the gap between the rectangular plate and the inclined surface is filled with oil. That gap is about 2 mm, so y is 2 mm. So here the surface area of the plate, that is 25 by 50 centimeters, is the area of the moving part which is in contact with the fluid, so that will be area. So surface area is, as I told you, it is 0.25 into 0.5, which is 0.125 meters square. So here weight of the plate is 400 newtons is given. So angle of the inclined surface with respect to horizontal is 40 degrees. So I told you, so this is the one. Okay, this is the inclined plate. So okay, so this angle is 40 degrees. So if this is 40 degrees, this will be 40 degrees. So weight is acting clear down. So I told you that the rectangular plate is moving along the plane. So therefore we want the component of weight in the direction of the motion of the plate. So therefore that this component will be, so this, if this is theta, so this angle will be theta. This angle is theta, then the component this will be w sin theta. So therefore f has to be w sin theta. So if you don't take f is equal to w, so f has to be taken as w sin theta. So therefore distance y, as I told you, distance is 2 millimeters, so convert into meters. So velocity is given as 2 meter per second. So therefore shear force F is nothing but W sin theta. So W is 400 newtons. 400 to sin 40 gives to 57.12. So therefore I told you shear stress is mu dou V by dou Y. Dou V by dou Y can be written as V by Y. So therefore mu is nothing but F into Y divided by A into P. So substitute the value of force, now not W, it will substitute as W sin theta, which is 257.12 into Y, which is 0.002, divided by the area 0.125 and divided by velocity, which is 2 meter per second. So therefore dynamic viscosity is 2.06 Newton second per meter square. So another problem of a rotating disc. So again inside a fixed cylinder, again here we have to use again Newton's equations of viscosity. Here a cylinder is 0.3 meter diameter, which is rotating inside a fixed cylinder which is of 0.31 meters diameter. So again I told you that distance between the moving part and the gap between the moving part and the fixed part is 0.31 minus 0.3 divided by 2. So therefore that is why. So length is given, which is 0.3 meters. So you have to find viscosity if the torque is applied. So here whenever torque is, so you can find out force. So force into distance, that is F into R, will give you torque. So always we know that the external torque should be equal to the internal torque. So that's the concept used here. So now the external torque is given as 0.96 Newton meters. So diameter of the stationary part is outer cylinder, which is 0.31 meters. Diameter of the inner cylinder is moving part, which is D, which is 0.3 meters. So length of the cylinder is given as 0.3 meters. Torque is given as 0.96. Now speed of the cylinder, which is given as 60 rpm. So now I can find out the distance y, which is 0.31 minus 0.3 divided by 2, which is 0.005 meters. So this is what the external cylinder, which is of point. So this gap I'm trying to find out, which is y. So this is rotating. Inner cylinder is rotating. So now I want surface area of that inner cylinder. So it is pi d into L. Okay, so D is, you have to take it as 0.3, not 0.31, multiply by L. So you'll get 0.2826 meters square. So velocity is, you know that V is equal to R into omega, but omega is nothing but 2 pi n by 60, or you can use pi d n by 60 as the formula. So it is always velocity is for the moving part. So D is for the moving part. So therefore pi into D, which is 0.3 into 60 divided by 60, gives 0.942 meter per second. So now torque is nothing but F into R. So torque is, so again what is F? It is nothing but you again got from shear stress. Shear stress is equal to mu into dou V by dou Y. So therefore shear stress is force divided by area. So therefore mu V by Y into area gives force multiplied by R, which is D by 2. So therefore substitute the torque here. Again I want mu, so area is known, V is known, Y is known, and D is known. So therefore I can calculate mu. So this is how it is calculated. The dynamic viscosity is 0.12 Newton second per meter square. So these are some of the applications of Newton's equations of viscosity. You can have either a ram which is moving in a cylinder vertically downwards, or it can be one cylinder rotating in another cylinder, or it can be something like a block which is moving on an inclined plane. So here one of the object is moving and other is stationary. So the gap is filled with the lubricant or some liquid which has got some viscosity. So here for all these cases we have to use Newton's equation of viscosity. Now this is a problem of bulk modulus of elasticity. A liquid is compressed in a cylinder which has got a volume of 0.0113 meter cube at some pressure which is 6.87 meganewtons per meter square, and then and has got a volume of 0.0112 meter cube at when you increase the pressure to 13.73 meganewton per meter square. So I told you that bulk modulus is nothing but dou V by V. So therefore dou P is nothing but the increase in the pressure, which is 13.73 minus 6.87. So therefore the data is volume is given. Initial volume was 0.0113. Because of increase in pressure, it is reduced to V2, which is 0.0112 meter cube. So pressure, initial pressure is 6.87 meganewton per meter square. So it is increased to pressure P2, which is 13.73 meganewton per meter square. So therefore I know that K is dou P dou V by V. So pressure increase in the pressure is P2 minus P1, whereas change in the volume is V1 minus V2. Original volume is V1. So therefore I get 775.18 meganewton per meter square is the bulk modulus of elasticity. One more problem on bulk modulus of elasticity. If the pressure of the liquid is increased from 7,500 kilonewton per meter square to 14,000 kilonewton per meter square, so therefore dou P is 14,000 minus 7,500 kilonewton per meter square. So here the volume of the liquid is decreased by 0.147%. So therefore dou V by V is 0.147 divided by 100. So therefore we can find out K, which is dou V by V. So dou P is nothing but 14,000 minus 7,500. So that divided by 0.147 divided by 100, which is 0.00147. So I'll get bulk modulus in kilonewton per meter square. So now using some formulas which related the pressure and radius. So I told you that pressure inside a droplet P is equal to 2 sigma by R. So therefore I will use this expression. So what should be the diameter of the droplet? Since droplet is given, so P is equal to 2 sigma by R. So here if the pressure inside is so much greater than the outside pressure, so that is P, which is inside pressure minus outside pressure, which is 0.0018 kg force. 1 kg force is multiplied by 9.81, that gets converted to newtons. You can multiply by 100 square to convert into meter square. So therefore the pressure is, so you multiply by 9.81 and okay, and also multiply by 100 square, so that gets 176.58 Newton per meter square. So surface tension is also given as 0.075 Newton per meter. So all are in SI units. So therefore I can use the formula P is equal to sigma by R. So by using P, so P I know, then sigma is known, so I can calculate R. So therefore, so multiply by 1000, so you will get 0.85 millimeters. So diameter of the droplet is asked, so it is 2R, so which is 1.7 millimeters. So this is the droplet problem. So if a soap bubble is given, then use 4 sigma by R. Calculate the capillary rise or fall in a glass tube of 2 millimeters diameter when immersed in water or mercury. The surface tension for water is given, and also surface tension for the mercury is given. So your first case will take in water. So then actually you know that when a glass tube is dipped in water, it will rise. So there is a capillary rise. Nothing is mentioned about the surface tension. So for clean glass and pure water, you can take theta as equal to 0. So if nothing is mentioned, sometimes they will give value, it will be generally less than 90 degrees. So specific weight of water, you know that its standard value, which is 9810 Newton per meter cube. Now you can use the capillarized formula, so which is 4 sigma cos theta by omega d. Okay, so 4 sigma is, that is surface tension, which is 0.075, cos 0 is 1 divided by 9810, diameter is given 2 mm, which is 0.002. So therefore I get the answer, capillary rise are 0.015 meters, multiply by 1000, I'll get 15 millimeters. So now second case is in the case of mercury. You know that the angle of contact, if not given, take it as 130 degree for mercury. So if and surface tension is 0.52 Newton per meter. So you know that whenever a glass tube is dipped, so there is a fall. So therefore cos of 130 is minus. So therefore naturally in the formula also you will get minus answer. So minus indicates that it is a capillary fall. So here specific weight has to be calculated for the mercury, because specific gravity of mercury is 13.6. So 13.6 into 9810 will give you specific weight of mercury. So in the previous case it was water, so that's why you used 9810. But here it is mercury, so you have to use 13.6 into 9810. Okay, so H is again 4 into sigma 0.52 into cos 130 degrees divided by specific weight of mercury, which is 133416 into D, and so diameter is 2 mm, which is 0.002. So we get minus 0.005 meters, which is minus 5 millimeters.